Now we turn to the t-test, which is also known as the student's t-test, because the statistician who developed it preferred to remain anonymous, just used the pseudonym of student. Here we have one variable that's categorical, and the other variable is continuous. That is to say, its values form a series where each one is more or less than the adjacent value. Once again, if we have two continuous variables, we can collapse them at the midpoint or at any other point to form two categories. The t-test is intended to answer the question, do the two subgroups, the two groups defined by the categorical variable, score significantly different from each other on some characteristic? That is, do they have significantly different averages or means? Here's an example from the two crises that we are studying. Each circle represents the score of one document. And if we look at how the documents and their circles are spread out over the range of power motivation scores, we can see that, yes, the war crisis does seem to have a higher average than the peace crisis. However, we can ask whether the difference between the average of the peace crisis and the average of the war crisis is really significant. Is that a real difference or just chance? Because two groups rarely will have exactly the same average score on any variable. This slide presents two different cases. Comparing two groups, we can call one group yellow and one group red. Notice that the two yellow means in pair A and pair B are the same, and the two red means in pair A and pair B are the same. So the difference between the yellow and the red means will be the same for pair A and pair B. Notice also, however, that the distribution of the two groups, the yellow group and the red group, is quite different in pair A from pair B. In pair A, the two groups have almost no overlap, and so we might think that that difference between the red mean and the yellow mean is much more significant, much more likely to be real than in pair B. Same difference in means, but the distributions are spread out a lot more. There's a good deal of overlap, and so that is perhaps less likely to be significant. Therefore, whether two means are significantly different will depend on two things: the difference between the two means, and then the dispersion, or how spread out the distribution of each of the groups is. The less the dispersion, the more tightly bunched cases are around the mean of a group, the more significant the difference in means. The greater the dispersion, the less significant. The dispersion of any distribution of values in a group is measured by a statistic called the standard deviation. How spread out is the group? A high standard deviation means very spread out. A low standard deviation means very bunched together. The t-test, or t-statistic, takes the difference between the two means and adjusts it or corrects it for the dispersions, the standard deviations, of the two groups. Because the distributions of the pair A groups are less dispersed, lower standard deviation or SD, than the pair B groups, the t-statistic for the difference between the pair A means is more likely to be significant compared to the t-statistic for the pair B means. Going back to our example, we see that the two means for the war and the peace crises, 10.61 and 5.89, are different from each other, and that the t-test, which takes that difference of 4.72 and adjusts it for the standard deviations, the t-test equals 3.64. The degrees of freedom are equal to the number of documents in each group minus 1, or 68 total. The probability of getting a t-value of 3.64 with 68 degrees of freedom is very, very low. Less than 1 time in 1,000 would we get a t-value that large. Or would we get a difference in means adjusted for the dispersion of cases in each group that large. And so we can say, yes, there's probably a significant difference in power motivation between the war and the peace crises. Notice that when we compare the means of the two groups, we have a more significant finding than when we use chi-square to compare high-low versus war-peace. When we use the means, we get a statistic, a result, that would occur by chance less than 1 time in 1,000 instead of 5 times in 1,000. That's because we are using all of the information of the continuous scores for power motivation instead of just dividing them into high and low. So you could say this is a more sensitive test. The third statistic that I want to talk about is the correlation or correlation coefficient, or R. We use it when both variables are continuous. That is, each value is part of a series where it is more or less than the adjacent value. The correlation assesses the relationship between two variables. That is, if one is larger, is the other also larger? Or if one is larger, is the other also smaller? That would be a reverse correlation. Correlations can range from plus 1.00, that is a perfect positive relationship, through 0.00, or no relationship at all, to minus 1.00, a perfect negative or inverse relationship. If we plot a correlation in 2 dimensions, one variable being vertical, one variable being horizontal, in a perfect positive relationship, all the cases fall in a straight line that slopes upward. The bigger one variable is, the bigger the other variable. A perfect negative relationship has all the cases falling on a straight line that slopes downward. The more one variable is, the less another variable is. And here's a plot of cases that have exactly no relationship at all. The cases don't fall on or near any line that could be drawn. We compute the correlation coefficient by calculating the distance from each circle, each individual case, to the line that represents the perfect positive or negative relationship. Considering all of the cases, the greater the total distance of those cases from that line, the less the correlation. In our study of these two crises, we wouldn't use the correlation coefficient to tell us whether the two crises are different in their levels of power motivation. We've already done that with the t-test. But we could answer other questions. For example, does power motivation increase as time passes during a crisis? Both are continuous variables, power motivation and time, measured perhaps in days. And are the correlations between power motivation and time different in the two crises? Perhaps power motivation goes up over time in the war crisis, but goes down over time in the peace crisis. How do we test that? We have 2 variables, the day of the crisis and the power motivation from all documents, speeches, media commentary, whatever we have, from that day. We calculate the correlation between power motivation and day of crisis separately for each of the two crises. Here's the war crisis, the crisis that escalated to war in Hungary. Each circle represents one document from this crisis. Its vertical location is its power motivation score. Its horizontal location is the day of the crisis from which that document comes. Notice the cases cluster somewhat around an upward sloping line. When we calculate the correlation coefficient, which the computer does for us, or for which you can find a formula in a statistics book, we find that the correlation R between power motivation and day of crisis is positive 0.36. The p value, the probability of getting a correlation that large, if there were no real relationship between these two variables, that probability is slightly greater than 1 in 100, or 0.012. We could say that this is a significant correlation, moderate but still significant, unlikely to have occurred by chance. Now, in the case of Poland, the circles do not cluster as close to a line, and the line is sloping downward. This means that the correlation as a whole is negative, but lower. In fact, such a correlation does not reach the 0.05 level. We can say p level is greater than 0.05. This means that we cannot say there is a significant negative relationship between power motivation and day of crisis in the case of Poland. There may be a trend, but it's not strong enough to lead us to be sure that it's different from a chance finding. Notice, however, that the two correlations are quite different from each other. In the Hungary crisis, a significant positive correlation. In the Poland crisis, a negative correlation, though not significant. From the correlation analysis, then, we can draw two conclusions. There is a significant tendency for power motivation to increase during the course of a crisis that escalates to war, whereas there is a non-significant tendency for power motivation to decrease during the course of a crisis that is peacefully resolved. I hope that this brief review, chi-square, t, r, and then underlying them all, the probability of the results that you observe being as large as they are by chance if there were no real significant relationship or difference beneath them. I hope that this has been useful and will help you to read journal articles in the social sciences. Thank you.